Hello, and welcome to Section 3, K-Nearest Neighbor. In this section, we're going to use satellite data, specifically image classifications of soil type based on satellite imagery. We'll explore the satellite data which classifies the soil type. We'll talk about the K-Nearest Neighbor algorithm in general. We'll build a model with KNN, and we will visualize the results. This video is focused on an overview of the satellite data and exploratory analysis. We'll take a look at the satellite data set, and we'll do a t-SNE projection and plot the data on two axes. This is an example of the kind of graphic or output you'll get when we plot our data. Now let's take a look at the code. Okay, we'll start by loading the MLBench package, which contains our data. We'll also load up the t-SNE package. Note that we've commented out the install package line, just in case you haven't already installed this package. We'll be using ggplot2 and caret to do some data splitting. Some data is not automatically loaded into the workspace when a package is loaded. Satellite is an example of that data, so we have to make a call to the data function with satellite. Now we see that our data is loaded, and we can see that it's 6,435 observations of 37 variables. Take a look at the summary of the classes variable, and we see that it's various soil, crop type, just a general classification of the ground. We'll use that Y variable to do a stratified split of the data and just look at about 20% of the data. Note that we're using a caret function here, even though we're not doing machine learning yet. We're just exploring the data. But it's a nice way to get a representative sample of the data. You'll see here we've grabbed X, which is all the variables of the satellite data and the 20% index. Y is the last column and the 20% index. So if we, for example, take a look at the dimensions of X, we see we now only have about 1,300 records. It's a lot more manageable for plotting. We can double check the number of unique classes, 6, which is what we saw in our summary above. If we go ahead and do k-means clustering, we can create a table of our clusters and our soil types. We see some patterns in terms of, for example, gray soil here is broken up amongst two clusters. Damp gray soil here is amongst mostly two clusters, a little bit into this one. You can just generally get an indication of, do the clusters seem to align at all with the classes in a way that encourages us to think that our model can separate these things out. We go ahead and do a plot of our data, just like the table below. We again see that the clusters mostly have some significant makeups. They're certainly not balanced between all of the different classes of soil. That's encouraging that our data will respond to machine learning well. Now we're going to go ahead and do t-SNE clustering. This is a way of visually clustering and separating our data out. It's a nice way to project data down to 2 dimensions. However, it doesn't perform great on super high dimensional data. So first, we're going to do PCA decomposition. We did this in prior sections. This is where we create a PCA model, and then we use it with the predict feature and grab the first 4 columns. Now we see we have almost 1,300 observations of just 4 features. We can run t-SNE to further bring the data down from there. This will take a moment to run. That should have taken you a couple of minutes to run, depending upon the speed of your machine. We see we now just have an x1 and x2. So we've projected the data down to 2 dimensions. If we plot that, we see this, which shows pretty good separability of our data. Bear in mind that all we've done is taking very high dimensional data, which anything beyond 3 dimensions, of course, humans can't really effectively visualize, and projected it down, which just means to take a look at it in less dimensions. This helps us understand that there's some hope in using algorithms that can separate out the data as we do in machine learning. We've seen a bit of the proportions of the data, and now we're ready to begin using K-Nearest Neighbor.